Okay guys, welcome to this recap session on logic gates and logical circuits and truth tables and Boolean algebra. What we're looking at here are the three logic gates that we use in computer science. We have the NOT gate, we have the OR gate, and we have the AND gate. Something that we see that's different on the NOT gate as opposed to the OR and AND is that it has how many inputs? For the NOT gate, it has one. It has a single input. They all have one output. With an AND and an OR, we have two inputs. That one input going into the NOT there, we can then express the logic of it. It's either going to be off, represented by 0, or on, represented by 1. In a NOT gate, what's going to happen if we input a 0? What happens in a NOT gate? It flips it. So if it's a 0, it will become a 1. If it's a 1, it will become a 0. Absolutely correct. With an OR gate, because we've got two inputs, it means we have 4 different combinations. And being that we've done binary now, we can see it's actually just counting up in binary. So you can imagine, you shouldn't have to write this yourself. There's like a 1 and a 2. So what number would that be if you had binary into denary? It would be a 0 1s and 0 2s make 0. 0 2s and 0 1s and 1 1 makes 1. What would that number make? What would that number make? 1 2 and 0 1s would make Jesus. Right, we're going to do this together. So I'm trying to give you a tip. Often you're asked to write out your own little truth table like this, expressing all the combinations. And what a lot of people are doing is they're just doing this at random. So it's like, oh, 1 1, 1 0, 0 1, some random combination. What you want to do is just do it in the combinations that you're counting in binary. So you can imagine that you had units here, lots of 1s, lots of 2s, you know, like we do the grid. If we have 0 lots of 1s and 0 lots of 2s, what number would that make? 0. For the next one, we've got 0 lots of 2s, but 1 lots of 1, which would make 1. And the next number is that we have 1 lot of 2s and 0 lots of 1. No, it wouldn't be. If you have 1 lots of 2s and 0 lots of 1s, it would make 2, because you were saying you have 1 lots of 2 and 0 lots of 1. Yes? What about the next one, babe? What do you reckon? You got 1 lot of... Exactly right, yeah? Do you see what it's doing? It's just counting up. That's how you do all the combinations. Sometimes, do you have logical circuits with 3 inputs? Yeah. And what you should do then, for all the combinations, is count 0, 1, 2, 3, 4, 5, 6, 7. All right, anyway. Emirhan, with an OR gate, if you have an input of 0 and 0, what's the output going to be? So this is the one where you can imagine, do you remember my phone? And I talked about unlocking my phone. I said that I could unlock my phone with either face unlock or touch ID. If I pick up my phone and I don't use either of those, what's going to happen? It won't unlock. So I haven't used face unlock, I haven't used touch ID, it will be 0. If it's I haven't used face unlock, but I did use touch ID, what's going to happen? Because it will unlock, right? In this case, we're saying it. Let me do, Mirhan, I'll let you to do the rest of them. What do you reckon? So I have used face unlock, but I didn't use touch ID. 1, right? And I've somehow managed to use face unlock and touch ID. What's going to happen? Well, it's going to unlock, isn't it? It can't unlock stronger. It just will either unlock or not unlock. So it will be, no. What represented unlocking? 1. There you go. That's how an OR gate works. What was the metaphor for an AND gate that I talked about? I talked about a safe. That's absolutely right. Now imagine we don't have a safe with a single lock. I have a safe with 2 unlocks. And I have to actually turn both the A key and the B key for it to unlock. I haven't turned either a key. What's going to happen? 0. I have not turned one key, but I have turned the other. It's still not going to unlock, right? Because I'm going to need to turn both keys. Exactly. Well remembered. Hey, what's the one combination with this AND gate where it's going to be 1? when you've both turned it. So actually, in an AND gate, you can just look for that one, can't you? And all the rest is going to be 0, right? And with an OR gate, you're just looking for the combination when they're both 0, and it'll be 0, and all the rest of the times it's going to be 1. To me, that's the way I look at these things. AND gates have one special case when they're both 1, otherwise it's 0. And OR has one special case, which is what? This is a very typical logic gates, logic circuit sort of question. What it's asking you to do is understand from this scenario, try and pick out what the different inputs are going to be, and then draw your own logical circuit. So we'll do this together. I'll read it out. An electric lawnmower will not start, so we're thinking that'd be a 0, right? Unless the lever operated by one hand is squeezed. So you've got one input, which is lever squeezed, either on or off. And it's a bit of a heavy hint right there, isn't it? About what kind of thing we might be using, right? And the safety button is pressed. So the safety button is either pressed or not pressed. The two inputs we can look at was lever operated, i.e. squeezed, and safety button is pressed. Those are our two inputs. And it's asking us to complete the truth table. And I had a suggestion from the audience. And what was the suggestion, Mohammed? Yeah, the one outcome will be 1 will be when what happens. So when the lever is squeezed here and the safety button is pressed, then it will be 1. Completely agree with you. What about all the rest of the combinations? Harlem, what about all the rest of the combinations? For here, about all the other combinations, what do you think the output's going to be? So, thank you, people. Really well identified. The rest of these inputs are going to be then... Mirham, what does that look like to you? What does that look like? About like the gates we looked at earlier, what does it look like? Do you remember we said the one has a special case when we both turn both the keys, which was... What are the different gates it could be? Think about what the different logic gates. Jagger's trying to do you a solid. Thank you, Jagger. Thank you, Jagger. You're exactly right. It's an AND gate, right? Because both this and this. And they're trying to help you out by actually putting the word AND in there as well, to be fair to them. So then we have to draw the logical circuit. How do we draw an AND? Do you remember the big tip is that you do a straight line? And then, if you were terrible at drawing, like I am, then it's a bit like a D, right? A bit like a D like that, right? But what really helps is if you've got a straight line, it makes a difference. How many inputs does it have? 2. So we got, we got 1 coming in here. 1 coming in here, 1 coming in here. How many outputs? If we label the inputs, would it be AB or oh, you said LB? Yeah, you can see that, right? Because it's L input, B input. Yes, Keely?
It reminds me of a charger because it looks like it's an AND gate, so it looks like a charger. That's how it reminds me.
Oh, like a plug, whatever. Yeah, it looks a bit like that, yeah. And what's the output going to be? S. Okay, let's have a quick look at this question. It's a similar one in the sense it's giving you a scenario. It's saying a boiler shuts down automatically if the temperature exceeds a value. So if temperature is over a safe value, so it's getting too hot, you need to shut it down because otherwise it can blow up, presumably. So I'm going to highlight that because like temperature exceeds its safe value. That's one of my ones. And then or the pressure exceeds its safe value. And we can see here, they've given us a bit of a kind thing here. We've got an or there. It's a bit of a hint, isn't it, really? So the combinations, we write them the same as before. So it's going to be 2 lots of zeros, 0, 1, 1, 0, and 1, 1 are all our combinations. And then we'll have the outputs. Hey, if the temperature exceeds its safe value, what should we do? What do you reckon? Go on, guys. So we're saying that the temperature is okay and the pressure is okay. Should we shut it down? No. All right. What happens if the temperature is okay but the pressure is getting too high? What should we do? Shut it down. And so what we're going to write down, we'll write down 1. What happens if the temperature is not safe, but the pressure is? 1. What happens if both and if we got to this position, we got real problems, right? The temperature's too high and the pressure's too high. We shut it down, which is a 1. Hey, what kind of a logic gate does that look like? OR gate, exactly right, yeah? And the tip for an OR gate is that you want to draw it with this sort of concaved way at the beginning. If it's AND, you draw that straight, and then that's the OR. The OR is like a bit more drawn out. My drawing skills are not that great. Wait, no, I'm doing it badly to make you guys feel better of your drawing skills. Was that believable, Jagger?
Yes. Right.
Thank you, Jack. Okay. How many inputs into an OR gate? 2. So we've got 1. Whoops. No, that's not good. We've got 1, 2. How many outputs? 1. What is the outputs that are going into it? It's T and P, and the output is S. There you go. Okay, a little bit of a switch up. This time it's saying determine what the outcome is at P. And I want you to actually have a go at drawing this yourself, because it's an opportunity to practice the straight line versus the curved line, and have a go at trying to draw one of these logical circuits. It's not testing all the combinations. It's testing if that's 1, that's 1, that's 1, and that's 0. What's the outcome? My tip to you would be this. What kind of a gate is this? It's a... So I would say 1's going into a NOT gate, so that would make it the outcome being 0. So what I would do is once you draw it, is then figure out what it is at all these points to then find out what P is. Okay, guys? Okay, so let's have a review about how this went. As we said originally, the NOT gate is taking in a 1, and then it's going to become a 0. For this AND gate here, what are the 2 inputs, Ollie, that's going to go into this AND gate? So what are the 2 values? So for this one, what's the input going to be? And for this one, 1 and 0. Remember with the keys, I've turned one key, I haven't turned the other key. Is the safe going to unlock? No. And we write down 0. So it's going to be 0 at this place. For this one over here, we've got 2 inputs. One is going to be, this is like my phone, remember? I can either use biometrics, like with my fingerprint, or I can use my face unlock. If I just use my fingerprint, but I didn't use my face, would it unlock? And we'd write down 1. And then finally, we're doing that same concept here. What are the 2 inputs in Mirhan that's going to go into this one? So this input's going to be, is it? 0. And so you've got 0 coming in here. You've got 1 coming in here. 0 or 1 will give you 1, although I can't actually get onto that spot. There you go. Apologies.